Okay, so I'm going to give you two mathematical sentences. And I want you to sit there and think about how are they the same, how are they different. If you can solve them, solve them. If you can graph them, graph them. Okay? So leave yourself room for objective, so kind of give yourself a couple spaces. Let's do x plus 2 equals 7. And then x plus 2 is less than 7. So let me clean that guy up. He's a little... So again, your job is to look at those two, write down in words. Could be just, phrases or whatnot, what they have that's the same, what's in common between them, what's different about them. Try to solve them, and then try to graph them. Okay? All right, so what are some things that you guys can tell me that are the same, some things that are different, and then could you solve them? I don't know why I always use Christmas colors, but I do. Okay, what's something that's the same, Jason, or different? No, not yet. Patrick.
The x doesn't equal the other x. They're the same variable, but they don't equal each other.
So that's something that's different, is that x doesn't equal the same value in both equations. That's kind of strange because they have all the same stuff, right? They have the same variable, they have the same operation, they have the same numbers. Why would they not have the same value? That's kind of interesting. All right, what's something else? Same or different? Anything, same or different?
They don't add to the variable.
Do they add? Oh, okay. So how about we approach it from what we learned back with what's on the left? What would I do to solve this?
Minus 2.
Okay. So to solve, subtract 2 from both sides. Okay, so to actually do the math is the same for both of them. Okay. Anything else? Same or different? So to solve, I'm going to do the same exact thing, but the answer I'm going to get isn't going to be the same thing. That's weird. Anything else? How about just physically, something that's the same or something that's different? Maddie?
They both have plus signs.
Okay, so both have the same operation of adding. Okay, Maggie?
One has an equal inside of one has
Ooh, there's a difference. There's one has an equals, the other has that symbol. We'll discuss that in just a minute. Allison?
They both have a 7. They both have a 7.
Okay.
And 2 and 1.
So we can say both have the same numbers. Can we say that? Because I agreed, they both have a 7 and they both have a 2. Anything else you guys want to add? Okay. So if I were to solve, we already were told just subtract 2 from both sides. So I'm going to subtract 2 from both sides. So in the first one, we get x equals 5. In the second one, we get x is less than 5. So let's look at their answers. If I were to graph the one on the left, what would I get? It's not an equation. It's not a linear equation. It's just a single variable. It's not two different variables. So how would I graph this? Serena? Again, this x is not a linear equation because it would say there would be an x and a y, and that would tell me that it's an equation that gives the graph would be a line. This one does not give me that indication. How would I graph, Maggie?
You just put a dot on the 5.
Yeah, we just go to where x equals 5, and we put a dot. And that's the end of what this one looks like. Okay? So we get a point. So this one gives a point as a solution. Okay, now, what would the graph of the second one look like? Johnny Ray?
Yeah, all one's greater than 5.
How would I physically draw? Do I do an x-axis and a y-axis? And honestly, this one, we could also do this. That's really all we need for this. Okay? So, Johnny Ray, explain to me how I would graph the x is less than 5. Is there just one answer like we had in the last one? No. How many answers do we have?
Yeah, a lot.
Okay, well, we have a mathematical term meaning a lot. What's that mathematical term called? It's called infinite. It's not all real numbers because it has a beginning point, right? So all real numbers means it goes infinitely in both directions. This one actually has a starting point, and then it goes infinitely in one direction. Okay. So what is the geometric shape that we're actually going to be graphing that indicates you have an exact starting point and you have an infinite other point? Miles. We're going to be drawing a ray. Okay. Now, notice that the graphs that you guys were used to drawing were x and y axis, but because this is only one variable, we actually have, oops, I want to make this smaller. We only have an x. Now, there's a couple of complications when I'm graphing this guy on the left, which, by the way, is called an inequality. I have to graph where my inequality begins. And there's a special way I have to graph that original point depending upon the information given to me in the problem. If it says that my number is less than 5, what am I going to actually mark at 5? Anyone remember?
Don't you put like a circle and then if it's like less than and you like shade it in?
Okay, so if it's less than I shade it in,
Or like I don't know, I just remember learning about that.
look, learning about it and knowing it are not the same thing. So we got to get to the knowing part of it. Lucas.
Don't you circle it and then like leave the inner space blank?
Okay.
And then if there's a thing that says it could be less than or equal to, that's when you shade it equal.
Okay. No, we usually say less than or equal to or greater than or equal to. So if it's just a less than symbol, it's an open circle because it says it can't include this number 5, but it's going to start as close to 5 as possible, and it's going to go less. So when I color less, I actually color in, including an arrow cap, on my number line, indicating the direction I'm going to go. Okay? So obviously today, we're going to talk about these inequalities, because we've already talked about equations before. And we're going to have some inequalities that are as simple as this one, where one step, I'm done, and we're going to get some that are as complicated as multiple steps, where you'll have to contend with fractions and decimals. Woo. Okay? All right, so let's get to our objective of the day. Well, more. Today we're going to learn how to solve inequalities That's objective 1. Learn how to, learn how to solve inequalities, and then we're also going to learn how to graph inequalities. Now these are simple inequalities. They only contain one variable. Because they contain only the one variable, then we're going to be graphing all of ours on number lines. And you will be doing linear inequalities, which are like linear equations, but with inequalities. And so we'll teach you more about that, because that's how we want to end up. All right, so let's go back and talk about some inequalities. Okay, so with an inequality, you're going to have, now he's probably printing. These are math sentences. No, this is part of the notes. Math sentences that contain these four symbols. Open, point, point, open, point, line underneath, point, open, line underneath. Now, you should have used at least the first two for the last several years. A lot of times when you're comparing, we use those two symbols. This one's greater than that one. This one's less than that one. And then we're going to go back and add the ones with the line underneath them. And then we're going to go ahead, obviously, and talk about which each one is and go from there. Spencer, you had a question?
What's the first word of parentheses?
That's not parentheses. That's the word contain. Okay. So this symbol means greater than. When we use it, we're saying like 3 is greater than -4. Okay, and in the very first chapter in the Green Book, they did some of that, where they were just looking at two numbers and compare them, and so that you can use that inequality to show a relationship between them. So a positive number is always going to be greater than a negative number. And again, what you're looking for is on a number line, if here's -4, here's 0, here's 3. If I graph 3 and I graph -4, -3 is farther to the right. The farther to the right you are, the greater you are. So that's why we can use that symbol greater than. Okay? Then we have the opposite of that. Well, sort of opposite. And this one means less than. And then less than would say that 2 is less than 6. So the open is always towards the larger number, and the point is always towards the smaller number. So you probably learned about the hungry alligator when you were in elementary school, that it always is very hungry, wants to eat a big number. And I kind of think about this as kind of bad, and probably get my hand slapped. But middle school perspective, you guys are rotten to each other, and you're always making fun of somebody, and you're always going, neener, your hair's too long. Okay? And so you're always pointing at the person you're trying to make them feel smaller than you. So if you think about it, inequalities also point at the number that's smaller. Okay? All right. Yeah, I know. Whatever it takes. We add a little line underneath, and now we've changed the dynamics. And we're saying your number is greater than, oh, hello, maybe if I could spell, or equal to. So that allows us to have things like this. 3 is greater than or equal to 3. Why, yes, it is. Okay, 3 is greater than or equal to 3. Okay, and then we have its cousin, which is less than or equal to. Okay, so again, we could have 2 is less than or equal to 2. We could also have 2 is less than or equal to 6 would still be true. Okay? As long as whatever's in front of the point is smaller than what's after the big open, then you're good. All right? All right, now, we had kind of some ideas about graphing, because with this, there's an infinite number of answers. Now, I know you might say, well, how could there be an infinite number of answers if we know where it begins? Shouldn't it be infinite minus something? And the answer is no, because we're continuing on in one direction forever and ever. That's called infinity. So you take away a few numbers from infinity, you're still infinity, right? So it keeps going on. So with inequalities, oops, tried black. You must graph the solutions of inequalities on a number line in order to fully understand them, or to fully understand the answer. I should say the answers. When we solved an equation, we got one number, sometimes two depending upon the situation. But when we are graphing, we have an inequality, we have an infinite number, and since infinite is beyond our scope of real understanding, we draw always our answers on number lines. So I'm going to tell you right now that the book doesn't remind you to graph, but you're going to graph all on your homework tonight. But again, it's just a series of number lines. You don't need any fancy graph paper. That's why it doesn't say star GP, because you don't need graph paper for this, okay? So to graph, we have different circles at the point in the inequality. So you will write a circle at the value of the inequality. So that's kind of a key thing. And then the second key thing is you write a circle. So whatever you solve your inequality and you get x is greater, well, ours was x is less than 5. So we have to put a circle at 5. Now, we're going to talk about what specific type of circle we get, depending on the inequality. And then there's the second part, and that's the ray part. Draw a ray. An array has a specific starting point and an infinite ending. So there's a dot or a circle for our case, and then an arrow. Draw a ray in the direction. Well, let's say this. Hold on. Draw a ray from that circle in the direction the inequality indicates. Now, I am making a huge assumption on these two things. Huge assumption, mainly on the second one. And it has to do with how you write your inequality answer. Where have I told you from the get-go, when you're solving an equation, the variable belongs in the answer? On the left. This is the reason why I've been stressing that with you. This only makes sense. The inequality is only going to reveal information if your variable is on the left. So I'm going to put a little variable must be on the left. Okay. Otherwise, the way the inequality is going, it's going to tell you to graph opposite to what you need to. So this is, if you just follow this, it's going to make this so much easier. So, must graph the solutions of inequalities on a number line in order to fully understand the answers, multiple answers. Write a circle at the value of the inequality and draw a ray from that circle in the direction the inequality indicates. Not indications. Let's try that again. Indicates. Okay. And again, to follow 1 and 2 and more so 2, the variable must be on the left. Okay. So let's talk about our inequalities. We pair them up two different ways. Pairing 1 has the less than and the greater than grouped together. When I do my initial graph and I make my circle, I have two types of circles. I have a circle that is not filled in and a circle that is filled in. The circle that's not filled in is called an open circle, and the circle that's filled in is called a closed circle. Open means the number is not a solution. So this would give us an open circle. I'm going to write in here, not a solution. And then my other pairing would be less than or equal to, greater than or equal to. And this one would be what we call a closed circle. So here's your circle, and then I'm closing it. That means value is a solution. There it is, part of the solutions. And again, this guy is just an open circle like that. Okay, so that's one way they pair up. So it has to do with having that little extra line or not having that little extra line. Okay, now we can group those symbols a different way. The direction that they're facing. I have a less than, and I have a less than or equal to. This tells me draw the ray left. And the reason why we go left, because that's where things are less than. Okay? I can also group them with greater than and greater than or equal to. In this one, I'm going to draw the ray right, because the numbers that are solutions are greater than that starter number. Okay. So a bunch of number lines, circles, some open, some closed, rays. Those are going to be part of the actual answer is the graph. Okay? Jason. Say again? That's the whole reason why we have to get the variable on the left, because the inequality is pointing the direction that you're supposed to be graphing. If you don't get the variable on the left, then your sign is not pointing the direction to graph. It's pointing the opposite direction. That's why I've tried to get you guys to always systematically solve your equations, variable on the left, for this very reason. Okay? So why don't we start a couple. I'm not going to write step-by-step how to solve. We've talked about how do I graph. So let's go ahead through a couple problems. Let's deal with one with fractions. Now, the directions are going to say solve and graph. Remember tonight, the book may forget to tell you to and graph, but you need to graph. But again, your regular paper and your spiral is fine. So let's have x plus 1/3 is greater than or equal to 3/4. Okay. So to solve this, we're going to pretend this says x plus 1/3 equals 3/4. And we just follow the same exact pattern we would to solve an equation. So what am I going to do to get my x alone? Yeah, I'm going to subtract 1/3 from both sides. I run into a bit of a problem, and that problem is, what's wrong? Signs don't really worry me too much. More importantly is the denominators, right? So I'm going to have to come up with a common denominator and create new fractions using those common denominators. So what's a common denominator between 4 and 3? 12. When the numbers are 1 apart, then the only way to come up with their common denominator is their product. Okay. So what did I multiply 4 by to become 12? So I'm going to do the same thing to the numerator, and the new numerator is 9/12. Now he's positive, so let's remember that. All right, and what did I multiply 3 by to become 12? 4. So I'm going to multiply the numerator by that, keep things nice and fair, and I get -4. And now I'm ready to solve. So I have x is greater than or equal to, and then what's 9 take away 4? So I get 5/12. So I'm now going to need to graph this. So I look at this inequality symbol, and it tells me two things. It says my circle is closed, and it also tells me to graph right. So normally I put in 3 numbers on my number line. That's all that I really care about. Sometimes 4 if it's a fraction. And I'm going to estimate the location of 5/12. So 5/12 is just shy of a half. So I'm going to figure out where a half is, go just shy of it. I'm going to label it. And I'm going to draw a circle at the 5/12 and close it up. And then I'm going to color to the right, and I'm going to be very exaggerated with my coloring so I know exactly what my answer looks like. Okay? What this says is 5/12 is a solution to this problem, as well as everything greater than it. Okay? What about something like this one? Negative 14y is less than negative 70. So how am I going to solve this one? What am I going to? Yeah, I'm going to divide by negative 14. That's the opposite of multiplying. And I'm going to tell you something crazy happens in this process. Do you guys remember what happens when you multiply or divide by a negative with inequalities? Trina? What ends up happening is that it affects the inequality. So this only happens for adding and subtracting. Take that back. It only happens for multiplying and dividing by negatives. Okay?
Negatives, they both have to be negatives?
Nope. Nope. It's just the guy that you're doing math with. Okay? So when I divide, I get y. It flips the inequality to greater than. And then I get 2 negatives make a positive, and 14 goes into 75 times. Okay? So when I graph, I'm just going to put the number that I want to graph is in the middle, and I like to put one below and one above. And then I graph it. Open this time. Okay. Greater than means open and color to the right. Okay. Yeah.
Shouldn't the line be vertical because it's a Y?
No. You can use any letter of the alphabet for these inequalities, and they're all going to be on a number line. And a number line doesn't go vertically for us, it just goes horizontally. Okay? All right, so let's write a little side note about that one, because that's kind of important to remember. When multiplying or dividing by a negative in an inequality problem, the inequality sign will reverse. So that means if it was greater than or equal to, it's less than or equal to. So you get the entire symbol, it just is going to flip around. Okay? Now, when you're working on your homework tonight, you've got lots of good practice. You have variables on both sides, you have constants on both sides, you have parentheses, you have fractions, you have decimals, you're going to have positives, you're going to have negatives. So, page 184, 17 to 51 odd, solve and graph all.